Don't try to sneak into your room like that. I know what you've got behind your back. Records. More new records.
We're in Switzerland, outside of Geneva. How far outside of Geneva are we? An hour?
About an hour and a half, yeah.
And we are in a metal fabricating company. What do you call this?
That's right. That's quite right. We are in the Swiss Watch Valley, which is the western part of Switzerland, and we are here because this is our main supplier for metalwork. The company here does all the machining for all the parts that go make the chassis, the casing of our equipment, including the back panel plate as well, and most of the parts inside as well.
So how does that work? You design how you want it to look and what you want it to be, and
Absolutely.
They take what you want and then they execute it.
That's correct.
And how long does it take for your original design to become a reality? I mean, does it go through various prototypes and they do one up and you go, that's not what I'm looking for?
Yes,
how long does that take?
Usually it takes about the best of a year. We have been in business now for 10 years. This year is our 10-year anniversary,
wow.
And we've produced 11 products. So you can see that it's about a product a year.
Yeah.
All the design is done in-house at CH Precision. We have mechanical engineers, electronics engineers like myself, doing the hardware design of the electric circuit boards,
right.
And then software engineers. They also do the low-level software that goes inside the units, as well as the high-level software like the app that we have to control all the equipment. Everything's done in-house. We don't subcontract anything as far as design is concerned, and then when everything's done for metalwork like we are for today, we send them CAD drawings to here, and they translate that into real things.
Right, and they do a pretty good job?
Of course, yeah, it's brilliant. And then they also do the anodizing. We partner up with them, and we bought the whole anodizing chain, which allows us to have a complete quality control over the finish that we want and make sure that we have consistency over time.
So you just said you bought the chain?
Yes, we did. It's ours, yeah.
Oh, and only does your products, or you?
It does only our products.
Only your products, and that's across the street.
It's across the street, so that's where we go.
Was that a major investment in money?
It's not nothing, yeah.
I'm sure it's not nothing.
For a company like ours, it's definitely a big investment, but it was the best thing we could do. Instead of struggling with quality, we decided to take destiny in our own hands and to do it ourselves. And that's how we ended up with that whole chain.
Oh. And you keep that facility busy making things. It doesn't sit idle for
we actually are sometimes struggling to keep up.
Really?
Sometimes.
That's good.
Which is good news.
No wonder you smile so much. Okay, so now we're going in here, or we go?
So that's the raw aluminium, how Mike receives it.
And where does this come from?
Ça vient
Allemagne.
from Germany.
Ah.
Yeah. And then this is the front panel button of our units. And this will give the deco cap that you have on top of the cover that you can screw. So that's the raw material. And then it's entirely machined, anodized.
Plastique. Ça c'est les pieds, il y en a plein là, il y en a 900. Pour les pieds.
Ah, these are the feet. The feet of the units. This is the steel.
Wow. Very heavy. And these are all the tools. These are all the machine tools.
C'est les outils. Donc le tournage c'est la pièce qui tourne et l'outil qui est fixe.
This is like the length.
Right.
The tool is fixed, and it's the parts that move.
Right. And these are extremely expensive.
Et les tours qu'on a ici,
Ça coûte cher, ça?
ça c'est 3500 francs pièce.
So
Alors ça,
C'est la tradition.
c'est la tradition. Hein.
Tradition.
Les outils de mesure sont de boîte en bois. Ouais, en plastique aussi maintenant. C'est plutôt les... Maintenant c'est en plastique. Pied aussi.
These are the feet of the units.
Le foot.
So you've got the foot raw, the foot finish, and then that's pushed into it. C'est quoi, tu la chasses?
Non, non, la chasse comme ça.
So it's
That gets
pressure.
pressed in. Yeah.
Ouais.
And it seems like they have parts of your units like all over the place. So when there are other companies' stuff, how do they keep inventory separate from what's yours and what's other companies? Oh, on paper. Okay. And then where are these machines manufactured? Are these from Germany?
Non, Austria.
Austria. Same thing.
Deux bibroches. One spindle, spindle, comment tu dis? La broche. Spindle. And second spindle. La broche, elle vient. Tac. Il travaille là. Et il travaille là.
So this is the biggest one?
C'est la plus grosse, celle-là?
The biggest.
Au niveau du tournage, c'est la plus grosse. Ça, c'est un passage de barre.
This is the biggest lathe.
And so what is he machining in here now? Do you know?
Qu'est-ce que tu es en train d'utiliser là?
En fait, je suis en train de faire une pièce. Donc ça c'est, on vient chasser un tube. Et puis moi j'usine toute la pièce ici. Et après je vais à la presse derrière et je viens chasser le tube.
So he's actually machining the feet at the moment over here.
I see. How long does it take to make one of those things? Do you know?
Combien ça prend pour faire une pièce? Combien de temps ça prend pour faire une pièce?
4-5 minutes à l'usinage et puis quelques secondes pour la presse.
Okay, so it's about 5 minutes to machine one
each
piece,
one, yeah.
and then if you come with us, he's going to show you the where he presses the foot inside the
Wow,
bottom
this
bit.
is pretty. This is a big place. And this is the vintage side of things.
Yeah, absolutely, and that's where he presses the
Donc ça c'est la presse. Et puis donc on sort la pièce. On met un posage pour bien le centrer. Une petite pièce en laiton. Pas faire acier contre acier. Et puis hop. Et là on sent qu'on est au bout. Et après on relève. Hop. Et après on mesure avec l'équerre pour voir si c'est s'il n'y a pas de jeu et s'il est bien du premier. Enfin, s'il est bien. Et autrement faut leur toucher.
And that explains why when you try to pull that out, it doesn't come.
You need to be as strong as that machine.
Yes.
Comment?
C'est pour ça que quand tu tires,
What's interesting is that in the old days, everything was green. That was the color of everything. Green.
yes, it was.
And now everything is red and gray.
C'est une rectifieuse, donc c'est une meule qui tourne.
It's a rectifying machine to flatten things. The
La
piece
table.
stays there and then everything moves up, backwards and forwards, left and right, and it makes sure that everything's perfectly flat.
And what goes like a panel? Finished
Ouais,
panel?
exactly, ouais.
Yeah. Where are the finish? I don't see any panels. Are they next door?
It's coming, it's coming.
More tools. Look at this.
Alors ça c'est une machine 5 axes. Donc là c'est l'outil. C'est l'outil qui tourne et la pièce qui est fixe.
On this occasion, it's the part is fixed and it's the tooling that works around
La grande différence entre le tournage et le freinage.
Right. I've seen
Et
this.
là c'est du télécommande. Le robot est chargé entièrement de télécommande.
Okay, so these are the remote controls for our equipment. So you can hear, you've got a feeder here. This feeder is the feeder, and then you go into there, and then you go and you can work overnight with the car.
Oh, really? It's like an assembly line of stuff.
Yeah, it's full of remote controls. Which are
So these are all for their remote controls. Look at how many remote controls they're making. So it's just, you know, just in case you think this is like a very tiny business making these really expensive amplifiers and electronics, look at how these are all remote controls sitting on like Stairway to Heaven up there. And the Eco Tower 60.
That's the finished product.
How long does it take to make one of these?
It's about 15 minutes.
That's a lot of time on a lathe like that. You know, what's interesting is I know none of us that own these kinds of products. We get a piece like this, and we don't really appreciate what it takes to manufacture and to design it and to lay it out like this. I mean, look at it's a shame that you can't see inside when you buy something to see what's going on with it.
Is to do the inside of that.
Right.
That was done before, so that's and then that's fed again into it to do the outside bit, especially that curve, which is quite a tricky thing to do.
Right. And you know, I know that how it works is you just get something like that and put it in your hand, and you just take it for granted that it's there.
Yeah. So you can see, the inside has been done, and then you need to do the
Right. So that's the unfinished outside.
The feeder is going to move.
Oh. I don't know about you, but I find this really fascinating. This is all to make the remote control to put in your hand. It's insane. In you go, baby.
This is a laser engraving machine.
Yes,
so all the seal screening are on the back of our equipment. So what it does is it burns the anodizing that's been done on the plates.
Right.
So you've got the computer over here, load the program, and then we'll do it.
Every time I see these kinds of hookups, this machine with the computer, it's always an old computer. It's always an old computer and a new machine. It's interesting.
What I suggest is we're going to go maybe to the anodizing plant now, because they are working, but they're working until 12 o'clock on Saturday today. And then we'll come back to finish off what's here.
Okay.
Yeah? C'est quelque chose qui...
I haven't been to too many factories where this is the view from the factory. So now we're going over to Usinage Hall. I'm terrible in French, I'm not even going to pronounce it.
1000, exactement 1000.
Yeah, we have 1,000 meters of elevation.
And does the elevation affect the machining in it in any way?
No. On anodizing, yes.
Look, they welcome me. They just welcome me. Oh, Fremer.
No, it just says close the door.
So this is done by hand, each one of them?
It's done by hand, absolutely, yes.
So the way we assemble the thing is we have the plates, and then we have these little bars, and these little bars are assembled. That allows you to assemble the thing, and then we have little guides that allow to pins, I would say, pins that allows you to assemble things and make it all together without having any visible screws.
Right.
So that's where the pin is going.
I see.
Inside here, and then it's going to be the same hole in the front panel, because that's where the front panel goes, and that allows to make sure that this part and the front panel will stay lined up properly. So you can see these things here. These are where they put these extra holes that they use after that to hold the part when they going to dip that in the bath, in the anodizing bath.
I
So
see.
these are things that we don't design. They add these things here in order to be able to hold the
To
part.
finish it off, right. Wow.
That's the 10 series.
Oh, that's the new one.
That's the new one.
Ah,
So you can see it's got the straight line instead of having the curve.
Yeah.
So that's the new design for the 10 series.
And that's the real typical.
And that's the M10. So that would be the L10, and that's going to be the M10. So you can see with the straight line as well.
Yep. And this is where the anodizing. It is sort of like taking the lacquer and so it gets coated. Anodizing is a
Yeah, so basically you have
It's an
to
electro-
rinse and to use kind of chemical first to remove all the oxide and everything.
well, that's what this is just the cleaning part.
The part here is cleaning,
Yeah.
and then this part over here. So it's cleaning, rinsing, cleaning, rinsing. And this is the anodization process, the real one.
So this is similar to electroplating.
It's exactly the same. Yeah, exactly. And then once the parts goes out of this bath, we can color them. So we have a few baths for this. This one. That's the regular
Black.
light color.
Electro.
Yeah. This one is for rinsing. I think this one is the anthracite, the dark gray. And once you have the color which goes inside the metal a little bit, you have to seal everything.
Right.
So the last bath, like this one, is for sealing.
So how long does it take to do one panel?
So one panel, if you start from the first pass till the end, it's 10 plus 1 plus 1 plus roughly 20, 25, plus another 5 for coloration, and 45 at the end for sealing.
So it's like almost 2 hours
It's close to 2 hours.
for each panel.
Yeah, but you can run in parallel, in fact.
Right. Right. One to the
This,
next. Still,
it takes 45 minutes, let's say,
Yeah.
because that's the longest one.
for each panel, and it's,
Well, we put a few of them.
okay. Oh, still.
Oh, but still, yeah,
Yeah.
for sure, yeah, it's a long process.
And then you end up with.
See the new model.
And what state is?
That's an M1 chassis, and that's the front panel for the M10. And the M10 is going to be almost twice as deep as this.
Really?
It's got 6 feet.
And how powerful is it?
300 watts in the NATO, or 1,000 in Bridgeway. This is finished as far as the treatment is concerned, and then there's going to be the laser engraving. It's going to be done here,
Right.
and next to the buttons. This is an extremely important part here, which is making sure that the color is right. So this is the model that they use against every part that comes. These lights here are reproducing the total spectrum in order to make sure that you don't get fooled by what you see.
It's really impressive and amazing. So what would happen if you took the electronics in your stuff and put it in a plain old plastic case instead of going through all this work to make a beautiful thing? What would happen? Would it sound the same?
No, it
No,
won't.
would.
No, definitely not. Yeah.
This is the block that holds the oscillator for the T1, the clock generator that we sell. So inside it here is a printed circuit board, and you've got this area here where the oscillator goes. All this is used for multiple reasons. One is to isolate the oscillator from external vibrations. So this is mounted on damping pads, alpha gel pads. So it makes sure that it's very immune to everything on the outside.
Right.
Because it's very heavy, it creates any damping at a very low frequency. And also it's an avant control oscillator, so you need to make sure that the temperature won't vary, otherwise it will affect the frequency.
Right.
And having that sort of inertia inside it helps as well prevent any shifts in frequency. Here are the 4 pads with the alpha gel thing, where that sits on the bottom of the chassis, and then you've got these 4 things here that will prevent any big, large movements. So it's completely free, but you can't go any quite far. These are the radiators, the heat sinks. So they also machine here. This is an extrusion, and then they machine here, and then they are also anodized in this chain in order to get the black color. So you can see that's the bottom bit. So you've got all the mounting screws over here,
Right.
and then here you have this is for the M1. So these are where the power transistor.
Right.
Power transistors are going to be screwed, and these things here are where the loudspeaker wires are coming out. So you've got the board that sits over here, and then the loudspeaker cable comes out to go to the binding posts.
Right. Beautiful.
3 different colors. These are the 3 different colors for the 10 series. So you can see also the new shape, not the wave,
Right.
the straight line. These are the 3 colors that will be available. The 10 series will have the capability to do mix and match of the colors. So we'll have a configurator that will allow customers to specify what color they want for the front panel, for the buttons, for the sides, for the top. Everything can be customizable.
And so to design and prepare a new product like this must cost a lot of money.
We confirm.
To
yes.
launch a product.
Yes.
Yeah, a lot. And so when are you launching this product? Is it launched?
We launch it in Munich. It's going to be seen in Munich for the first time next week.
So you show it, and then you hope to take orders. You hope to get orders from dealers. So this is like a big deal. This
It is, yes.
is a big launch for a company of your size to have.
Yes.
This.
Well, it's the 1 series of products is more or less complete, and we have the 10 series of product coming for our 10th anniversary.
Right.
So we
And where
celebrate
does
the
this,
launch.
in terms of pricing, where does this line sit? Is this above the M series?
It is
It's
a high
above.
line. It's a high line.
So it's a high end?
So
A high
what-
end like compared to your budget stuff that I just reviewed.
Yeah, what we did with that 10 series is to start with what we've learned over the last 10 years.
Yeah.
And improve on what we could on that by having products that cost more allows us to have more money to actually make things even better than what we could do, and select better components, electronics components, make sure that the metal work is also done in a specific way, so everything goes as an improvement, a step up from the 1 series.
Wow.
It's also really a customizable line of products that we introduce. So people can really build their own product according to their taste. They have the color of the choice of the colors. So it will be each product will be kind of unique product, let's say.
Right. And so the line consists of monoblock amplifiers,
Monoblock
preamplifier.
The preamplifier.
What
So
else?
it's going to be the names are going to be the same. So it's going to be for the 1 series we have the preamp being the L1. That's going to be the L10, the M1, the M10.
Makes sense. Makes sense to keep things consistent.
Similar. And who knows? There might be a P10 and a C10. Who knows?
In 6 months, you can do a whole nother line. Why not?
Why not? It took us 10 years to do the first series.
Right.
Yeah,
But
we
that-
should
but
be
you've
able
learned.
to.
It took you
We should
10
be
years
able
to
to do
learn.
it in
Now
6
you're
months
ready to
now.
go.
We know what we're doing now.
Okay, so we've seen everything here now?
Which is the color you like the most?
For the one that you're going to give me for doing this video? Did I say that? No, I'll have to cut that out because people take me seriously. Me personally, I like that. It's this old school.
Old school.
But that's me.
You can have it If you want it, you can be the first ever person to have it.
Of the remote
Of the remote control shell.
If you want to keep it.
That I'll take. I'm taking this. I've been bribed, okay? If you think I've been bought off for a shell of a remote control,
You're the first
you won't
one to
believe
see
a
it.
word I've ever...
The very first person to see it.
And now they'll all see it at home very quickly too. Because
They might.
So quickly. So let's just say this is a 3-year facility, and that you guys own this, and you put it here.
We built it for.
You built it for right.
Manufacturing.
This is to manufacture, to anodize all of your products. Right. You didn't contract this. You made this.
We started by subcontracting,
Yeah.
and it was a nightmare. So we decided to build this by. Into this room, it's to 200,000 roughly.
200,000.
But it took us, Mike and me, close to 6 months to get the right recycling.
Yeah.
So I let you imagine this,
Yeah.
the nightmare it was.
Made it. Is it worked out exactly as you expected?
Yes.
In terms of consistency and quality?
Yes.
And ultimately, it saves you money. Ultimately.
At the end of the day, absolutely. Because
Yeah.
if you use the regular subcontractors, I would say you have to trash about one piece out of 2. You reject one out of
50% rejection,
50%. Yes.
but now you don't.
Now we can use 95 to 99%.
Okay, well, so that's a no-brainer.
Yeah.
Okay, let's go back to machine shop. And how long does it take this gentleman to assemble one of these chassis? It must take an hour?
It's close to an hour. Yeah.
Wow.
Yeah. But it's also a quality check in a way, because once they've done this, they know that's the part.
Chassis, the empty chassis, is then put into each of the packaging. You've got the cardboard box. The cardboard boxes are reused all the time. These are all the same one, but the foam inside comes with it, and that's the foam that's going to go with the unit eventually.
Right.
It stays with it all the way.
You going in this way?
Yeah, these are the units front panel, the raw material for the front panels. There's a lot of machining.
Ça c'est les fonds de DA.
The D1 seat drive. This is a steel plate.
Et là on a tout ce qui est côté brut, capot brut derrière.
Okay, these are the sides for the machine, all the raw material for the sides.
Okay.
Après, si on va par là,
When it's been machined,
ça c'est des capots,
Just
ça c'est
machine.
des fonds, ça c'est des côtés, face avant des 1.5, face avant de M1.
in front. That's the M10. That's the M10 side. Wow. So you got front panel, then 1 foot, a foot, and a foot here. So when it's machined, you're far off being finished, because you've got the raw thing with the right shape.
Right.
But then the tricky bit is you need to prepare it for anodizing, and you need to have the right finish, and that is a completely manual operation that's been done here of polishing. You got several, you go several times.
Ah, c'est encore des capots, hein.
That's the price. You can see that's an M1. That's an M1 with the opening.
Right.
The sides, the front panel for all the units. That's the A1.5.
Des sides là.
M1s.
One at a time. One at a time.
So when it's there, if after you finish, if you press on it with your finger, you can't see anything. You put it in the anodizing chain, and then it appears straight away. So it's extremely important as well to be extremely clean, and then in order to make sure that you won't have anything left after anodizing.
And it's his judgment as to when this is done and ready. So it's his judgment.
Yeah, they are very specialized workers.
Yeah.
Face avant. Prête ton première opération.
So that's the inside, so you do it in 2 steps. You go the inside first,
Yeah.
and then you turn it around to do the outside, especially the curve.
Okay, so
choses
this
qu'on a
is the
besoin.
CAD drawing for your remote control for the M series.
Et puis ici, on crée l'outil.
So these drawings are what we get.
Et en fait, ça reflète ce que la machine.
from us, and then this
que la
is a
machine va faire.
simulator of how to machine it. So every step so it's just putting step by step all the operation that needs to be done. So that
We're here at CH Precision, and this is their production facility. They have two offices here. This is the production facility, and as you can see, it's a very picturesque area. Well, all of Switzerland is picturesque. So let's go in. And remember, this is a Saturday, so there's not much happening here in terms of production, and it's also just before the Munich show. So what we have here on these pallets, this is all of what you're shipping.
That's absolutely correct. Then we have a few pallets here that are going to be picked up tomorrow. No, sorry, Monday morning.
That's a lot of stuff.
Yeah, we are exhibiting in a few rooms.
And so if you're in a bunch of rooms sharing it with other people, who picks up the cost of all this shipping? You split it with them, or you do? It's all you. So running a show like this, doing a show like this is extremely expensive.
It is, yes.
Yeah. People don't appreciate that. And why is it that some of these things are in flight cases, and some of them are in cardboard boxes, and some of them appear to be in...
So, yeah, this is the setup, basically, of the room. So decoration, everything.
Oh, I see, okay.
And these are the units, our units. And this is the big news of the show, one of the big news. In fact, here inside this cast, here is the Texas Air Force Zero.
Oh, the Zero is here.
The Zero is here.
Oh, this is the Air Force Zero is
Air
here.
Force Zero, this one, yeah.
And back there too, right?
Yes, probably.
That looks,
Yeah.
yeah. It's a big thing.
It's a big thing, very heavy.
And so is this where things are assembled? Right
yes.
here?
Yeah,
Yes.
exactly.
So we dedicate lines like this to manufacture our parts in batches, and this is what we call the final assembly. So there is just in the next room here where they build all the little sub-assemblies. So prepare these things, we stock them, we build them by 100 or something like that, and that allows us to then build units extremely efficiently, because we have all these blocks which have already been tested, and it's just like Lego.
Sure.
Mm-hmm. Behind you, you've got all the circuit boards in the black boxes. So these boards have been pre-assembled, so that all the electronics parts have been populated, and then tested here. So they get sent here, tested with our test equipment, and then ready for being assembled.
And then once it's all assembled, you test it again, obviously.
Yes, you do.
Yeah.
And that goes back
Final
in there?
Well, there's a room for testing the boards, and then we have like a trolley which has another piece of equipment that we used for testing the equipment. So we have different various procedures for the.
Are we going to see that?
parts of it.
Are we going to go back and see all that stuff?
Yeah, you can.
Okay.
Yeah.
And so these boxes here have pre-assembled modules, we'll call them.
Exactly. We do not receive things like this exactly from the subcontractor, but we do receive the board populated, and then we mount the
This looks familiar.
spacers.
You saw that this morning.
Yeah, exactly. We mount the backplate, the connectors, and we test this board.
When it's tested, it gets the green.
That's why you have a green dot. So this board, we know that when we mount it into a C1, it's a DA converter board. When we mount it, it works.
That's right there.
So that's typical process here. We test all the boards in performances, and we know they work. Then we can do the final assembly, and we test the full unit.
If you look here, this is the typical chain of production. You get 6 units per row. That's the I1. So these are freshly finished, and And
So this is an integrated amplifier.
this is the integrated, our universal integrated.
asking-
This unit was introduced last year.
Last summer. Yeah.
Last year, something.
Last year, okay.
Less than a year ago.
Okay.
Mhm.
Has this been a successful product for you?
Yes, it has.
Yeah.
Yes, it is.
It's fantastic. We're really happy with that because that's the solution for people who want to have a small system. When you want a small system, well, you've got everything because that's a condensed version of 4 of our units.
Oh, so there's a D to A in here too?
It's
Oh.
the hub of that unit is digital. So everything analog gets converted into the digital domain.
So this has got the phono preamp section, but it's a digitized phono, which I've
Correct.
heard,
So
which sounded actually very good.
Yeah, the first stage of amplification is the same one as the one in the P1, so in the analog domain.
It's,
Right.
it's the current
When-
mode input.
Basically, when you get from a very small signal to normal line level signal, at that point we convert it into the digital,
Right.
and we apply the EQ curves in the digital domain.
Right, which has its advantages for sure.
Yes.
And what resolution is the conversion at? 9624, 19224?
It's DXD.
DXD.
DSD?
DXD, yeah.
384.
Oh,
384.
oh, way up, way up.
Yeah.
Mhm.
So my friend David Robinson at Positive Feedback gets all excited by that. He likes everything has to be double, quadruple, 8 times DSD, 12 times DSD. The more times DSD, the better.
Yeah.
And so in America, what does this cost?
The basic model starts at 38,000. And as you can see here, you have slots for adding option cards. Just like the ones that you have at the back of the C1, these
Right.
are options for digital inputs here, or the analog inputs are factory fitted, but you can fit a piggyback board with a phono input on top of it.
Uh-huh.
Okay, and then here you've got a slot for the synchronization card to get an external clock syncing into that unit. So as far as digital inputs are concerned, the unit comes with the normal AES, SPDIF and Toslink input.
Right.
It's got our CH-Link HD proprietary input allowing you to connect to a D1, and you can add another board which is either USB streaming or Ethernet streaming.
And at this point, those are very important in the world of digital streaming audio.
Absolutely, yeah.
Are you finding more people ordering that now than they were before
I think
when you
so.
started? And are people up starting with that, or are they adding that you're finding?
More and more they start directly with the Ethernet or USB streaming.
It's
Yeah,
one of
whereas
the,
it was-
it's one of the other.
Yeah.
Yeah, in the past it wasn't true. They were upgrading
Yeah,
very often.
yeah.
Yeah.
And you can upgrade all of your products like that, right?
From day
That's
one.
the modularity is
Yeah.
a really useful
That's
thing.
that's
like that,
right.
Yeah, from
Yes.
day one you
It's
can.
very simple to upgrade. Maybe if you come on the other side, I'll be able to see that. But, when the lid is on, these modules are held by just these 2 screws, one at the top and one at the bottom.
Yep.
And when you remove these 2 screws, they can simply slide it out, and you can see there's a little guiding rail inside here, and then you've got the connector at the back. So you just slide it in and then push it in, and then you put the 2 screws and you're done. So you can actually do it yourself.
So do you suggest user upgradability, or you prefer having the dealer come and do it?
You can do it. We're fine with that. We think that the level of service for the products that we have makes it logical for the dealer who sells the car to actually come and
Yeah,
install it.
of
for
course.
So the structure of such a unit is starting with the mains power, going into here a mains board that allows you to select the voltage if you are in 230, 115 or 100 volts. You can select it.
Oh, so these are all like universal
They are.
They are,
designs.
yes.
So you
Yes,
don't
they are.
you can use them
It's
all
very
over the
simple
world.
because you've got here, if I can take it out, I won't be able to do it.
You need
Here you go.
nails.
There you go. Right. Here you've got a little something like that that
Huh.
allows you to select which one you want.
Just flip it around.
Yeah, you
Oh,
if you're
that's
that
cool.
230. So these units are totally the same for, everywhere around the world.
That's really smart, right? I mean, there's no doubt that that's a smart thing.
So the selections then gets done here and feeds the big power transformer, and then these are the secondary windings of the transformer supplying the various parts. These are the power ones just to power the two amplification boards which are here, and then these two here are the low power ones to select all the front end here. So the two boards, just like a normal stereo board, these are based on the A1 circuitry topology, which is the same as the M1 topology. The only difference with the A1 is the number of output stage transistors, because this is being a stereo unit, you don't need as much current than if you were in monorail or in bridge mode, and therefore you don't need as many output pairs of transistors.
Okay. What's next?
Well, we can go here. We've got the amps, power amps.
And so on the floor there, you've got more power. Are these power modules specific to that unit we just saw, or is this
These are
usable?
the I1s. These are the I1s.
So it's only for the I1s.
Yes.
Yeah.
So this is typical of what I was saying when I was saying you build these units as a Lego, because this has been prefabricated here before any of the batches of production have started, which means that when you have to build an I1, you just take it and put it in. Well, doing this on a single unit basis
it's crazy.
to be crazy.
Yeah.
So if you do it in batches like this, then you're much more efficient, and then it gets tested as well. So you make sure that it works before you fit it in.
How many people are here working on an average day?
3 people permanently.
Small number of people can do a lot.
Yeah.
Yeah. Oh. Okay, so that's good to run a lean company. Why not? And so
That's the power amps, you know?
this is familiar.
It's familiar, yeah.
Yeah, the M1.1.
From the back, and the A1.5 over here. The new ones, which replace the original A1 design.
Yeah, that's the latest edition of our range, the A1.5, and it replaces the A1. So it's the bigger brother. Inside you've got the same card. Well, it's actually not.
And explain to people watching what this is all about. I know what it's all about, but there's a plate that goes over here that you can remove.
That's correct.
And then
that's just the decorative little disc.
Right.
It covers the foot of the unit. So the foot goes all the way through to the real foot that you can see on the outside, and that's the thing which has been pressed in.
That we saw earlier,
we saw earlier. And then you can screw here another little part which we call the stacking cap. And that stacking cap allows you to then fit another unit on top. But more than that, you can fit what we call a spike inside it and then screw it in, and it will stick out from at the bottom and lift the unit, so the unit is then only held on 4 little points.
Right.
The spikes.
Now, can you do that and add a piece on top?
Yes, you can.
And how heavy can the piece on top be? Can you add a second? Can you stack monoblock amplifiers?
We to test it, we did a quite a fun thing. We actually fitted this, and then the 4 of us actually sat on it, but that stood on it, to see how strong it was. So it weighs, but it holds the weight of 4 CH members.
Wow, and no
one
problem.
of them is a little heavier than the others.
One is skinny.
One doesn't weigh anything, so he doesn't really count. So you could stack 4 of these on top. So people who are space challenged could just load them up.
Yes, you can. Yeah.
Well, yeah.
That's good.
The highest setup we've seen is 7 units, not the regular ones.
Yeah. Like this height, we had 7 units on top of each other. But these ones, I don't think we've ever seen more than 2.
I've never seen more than 2.
Yeah, I don't think we've ever seen any systems with more than 2 M1s on per side.
Right. Most people who can afford these have enough space to do whatever they want. Mm-hmm. All right, let's keep moving. Let's keep making it exciting.
That's the the trolley that we use for testing. So it's got one of those pieces of equipment called Prism Sound, which
Right.
is from Prism Sound. It's basically it's a generator of audio signals and then an analyzer. So you run this into the unit, and then the output of the unit goes back in there. And
Right.
then with the computer here, you can set a certain amount of tests and make sure that the performance is comply, because you've got a set of limits and it complies with what we want. So you can see here all the sub-assemblies which have been made to make our life easier afterwards. So all the transformers for the various types of units. Each unit that we have got a dedicated custom-made transformer. So it's been pre-assembled here. The back plates for that's the main section. I'll take one of those.
What's the average time that one of these modules sits on this shelf before it gets assembled into a finished unit and shipped out? Weeks, months?
Months, I would say a month. Yeah. So you can see how easier it is to have that in sort of separate modules. So that's done, that's tested, we're all happy with it.
You could sell this stuff in kit form so people could build it themselves.
Exactly, for DIYers.
Yeah, do it yourself, save a couple of bucks.
Love it.
Another parts. This is inside the M1. So
Transformer.
the transformer goes here, the massive one goes here. It's always mounted on a plate, which is then using these damping things. And then on top of it here, you get the audio side, the low-level audio side. So you can see here, these are all the transformers. These are all the transformers, how they arrive. So they arrive with
Where are
big
these
pallets.
manufactured?
These are Noratel transformers. So Noratel is one of the main supplier of toroidal transformers. They have recently bought Plytron, the brand, as well. So it's a large manufacturer. And they do everything on specs, so it's really custom made.
To your.
This is the preparation area, so that's where all the sub-assemblies get made. So these machines here allow you to prepare all the cable assemblies. So typically that machine here will cut the wires to length and then strip the ends off, ready for crimping. And this machine here and that machine here allow you to crimp all the little cables. So it shows you, where is it? So with these you can either do things like that
Right.
with that machine.
This is like an X1 module.
That's
here?
the next one regulating the
Yeah.
work module.
See, I knew something.
So you can see that this has been soldered onto that connector, and now it's going to be soldered onto the various points. You got all these points here.
Yep. And that's
That's
hand
gonna
soldered.
Oh yeah. Well, you can see one finished here actually.
Oh, yeah, there you go.
Yeah,
So there's one person is dedicated to that room, and she's doing all these things, this preparation
Wow.
part, all the time. For the other two to be able to do the assembly.
thin wires like this,
Yeah.
we assemble everything, but we are also doing this kind of cables for the power amps with the big copper lugs and everything, and it's also done here with the same tools, basically.
Yep.
So these also are pre-assembled. That's what you saw on the metal plate at the back earlier.
Yep.
So first of all, this is a sub-assembly that goes into the bigger sub-assembly, and that's typically the model.
And that's your model. That's the one you have keep around as a model.
Yes, you always take one of those, so you know what you're talking about, and you know that never goes anywhere. Over here is the testing area. So that's where all the boards, the electronic boards, are going to come. They always all end here. End up here.
As sub-assemblies.
Yes. So they are assembled. Typically, that's the I1 amplifier board, and we get the board. We assemble it in the room behind us. We assemble it onto the
Heat
heatsink.
sink, you're right.
And then from the heatsink we bring it here, and then we can test it. So if let's say we talk about an M1, then we have here an M1 which is missing an amplifier board.
Right.
So with these wires here, we can connect this. So we just lay the board horizontally here, we can connect it, and then we have the unit that allows us to test.
So this is a test jig. This amplifier is a test jig that stays here all the time, and you just
That's right.
pop in the amplifier to
That's right.
test it.
Yeah.
And you can do either channel with that one side open.
It's the same.
It's the same, so-
The left and the right channel are
Yeah,
exactly the
and
same.
so this hookup is the same.
Yeah, absolutely.
And-
And all the things you see, like this one and the ones over there, are all test jigs. So
Right.
they are. It's one. We have one test jig per unit.
Of each, yeah,
And,
of each
and then you
thing.
can test all the sets of boards that
Right.
go into the normal unit using these test jigs.
And do you mind telling me, since you've been in business now 10 years, what your success rate is as opposed to your failure rate? Let's call it success rate.
The success versus failure, you mean?
No, there's stuff's out in the field, people own it. Does anything ever go bad in the field, like blow up?
Honestly, no.
No?
Honestly, no.
No.
If it blows up, it's because they've done something wrong with it.
Yeah.
We've not had any amplifier, fingers crossed, touch wood, whatever, that has blown just by itself.
Yeah.
If they blow up, it's because there's a short circuit, a really bad thing that's happened to it.
Yeah.
Then that happens, but
Yeah. And
it's quite pretty rare because people. I mean, unlike you who plugs and unplugs things all the time,
Right.
people have got quite a static system. So once it's done, it just works.
Right.
And,
so high reliability, and let's say something does blow up for one reason or another,
Sure.
it has to come back here, or is there field repairs?
most of the time, things come back here if there is a problem.
Because you want it back anyway. You want to go through the whole thing,
You
I
do.
imagine.
You do.
Yeah.
You do. It depends on the country, actually. Some countries have got technical support at the distribution,
Yeah.
on the distribution side, and we train them to actually do repairs themselves, and then we can send them spare boards and things
Right.
like that.
Which makes sense.
Yeah.
Okay.
To give you an idea of the reliability is that we have nobody who takes care of the after-sales service. Internally, we have nobody.
That's good.
Yeah.
You like that, right? This is your transports for your.
Yes, it is, yeah.
Are those available still? Do they still?
No, they don't. No, they don't.
So what's how does that affect you? I mean, what's going to happen with that?
We had to stock lots of them. That's what we decided to do. There was a big investment in order to be able to do that. No, that's not the stock.
No, I was going to ask, but you beat me to it. So you think you're good for the next generation of people? You have enough of those around.
We can supply for a few.
So what's going to happen with SACD drives? There's just not no one's going to make a good one anymore that they're willing to.
Not necessarily. I would say now the Japanese companies still manufacture SACD drives.
Yeah.
Only them, and they don't want to supply
Anybody else?
OEM.
Yeah.
They
How
want
nice
to
of
keep the
them.
market for themselves.
Oh, that's wonderful. That's going to really expand the base.
Yeah.
We got this machine that is the latest edition that we do. So it's a printing machine that we use to print the front panels. So when all these glass panels that you've got here have got, as you can see, a little opening
Right.
for the screen, and this little marking here that show the model, and that's printed here now.
No.
We've decided to do that here because it's much more efficient. and,
That's the glass piece itself.
that's
Literally
right,
goes
the
in
glass
there.
piece,
Yeah.
that's right.
And that's what's up there.
So yeah, that's the stock of the machined glasses.
So I mean, you've really got an incredibly efficient system running here.
We try our
And
best.
what you do,
Yeah,
it's
we try
like
our best, yeah.
you have a large number of products that you manufacture, and you can assemble them in this not particularly large space efficiently with not that many people. That's impressive.
Trying to build things in sub-assemblies in sequence like that allows us to be much more efficient. And wherever we see a problem, we tackle it and typically that printing thing is the answer to a few problems where the printing quality wasn't to our standards.
Where was that done before? So, and outsourced
It
something?
was outsourced.
Yeah.
It was outsourced, and yeah, it wasn't always the way we wanted it. So
And it's got to be because this is what people see. This is right in front.
Absolutely.
It's not like hiding inside where you can.
In fact, if it was a question of speed of printing, if you outsource, the company is going to print as fast as possible in order to make some money.
Right.
And you know, it's an inkjet printer, and you need to take your time and go.
Right. That's like what I tell consumers when they're setting up a turntable. You can have a dealer do it. He's going to be on the clock, or you can take as much time as you need to do it correctly.
Exactly.
And that's why you should do it yourself, I think.
So to give you an idea, the time for printing, it's 9 windows like this. So we have 9 windows right now on here. It's 6 hours.
For one.
For the panel of 9 windows, it's
9 windows.
6 hours.
Wow.
If you just think that you subcontract this, and it takes 6 hours to the subcontractor to print 9 windows, I'll let you imagine how much it's going to cost.
Yeah.
For us, okay, we invest into this printer, but then we can print overnight.
Yeah. I mean, time is still money to you too, but still, you can do whatever it takes to do it right.
On hidden time, let's say.
Yeah.
So it's okay.
Okay. Have we seen everything on this side of the world?
I think so, yeah.
So I just want you to see this because I think it's really interesting. This is a multi-pin connector for the X1 external power supply. So you know, most of us, we look at a thing like this, we go, okay, it's a multi-pin connector, and they solder them up, and that's that. But you have to see what goes on here with this thing. So each of those wires has to be soldered and shrink tubed.
There's
And
19 of them.
19 wires. And how long does it take for that to happen by hand?
The whole cable.
It's
so over
2 hours.
Yeah.
2 hours to make one side, both sides.
The entire cable.
Yeah, 2 hours to make one of these cables. And that's just for the labor. Okay, so a woman sits at this table here.
Yeah, she's got the soldering iron here.
Soldering,
so she's ready
yeah.
with that.
Right.
And then she runs the cable, which has not been soldered yet, inside
Right.
here. It comes over her shoulder here. She sits down here. Then she's got a little portable vise that she puts here to hold it, and then she can start soldering one by one over there with the little light here to make sure that she sees what she's doing.
Wow.
So that's the way it works.
And it's beautiful too. I mean, it is attractive looking. So obviously you've got a very lean organization here. So how many people actually work here on a daily basis?
So there's 3 people full-time here, and there's a 4th person who's the head of production. So the 3 people, there's 1 person that does all the sub-assemblies, and then the other 2 do the final assembly of the units. And then the head of production is doing all the management of the planning, and also part of the purchasing of all the parts, making sure that parts arrive on time and that the quality of the parts. He does all the quality checking when parts come in to make sure that we have things which are ready to be assembled, and we don't like arrive with the unit ready to go and find that something's not right.
Right. And then someone has to do packing and shipping?
These the 2 people will do from A to Z. They
Oh, wow.
really do the final assembly, all the way to the testing, all the way to the packing, cleaning, packing, and then putting on the pallet, circling it, ready to go.
Yeah.
And then somebody upstairs is doing the admin of for the shipment.
You have God working for you? What are you saying, somebody upstairs? What do you mean?
Well, CH here in Switzerland is composed of 2 premises. We've got the factory here
Right.
on ground floor,
Right.
so it's easier for forwarders to come and collect the goods.
Sure.
And then we have the development, the R&D side, and the admin side.
Let's go see that.
Yeah, let's go.
All right, so now we're on the other side. I think so. Over there is downstairs there. That's where the production is, and now we're on the other side, right over here. And this is where all of the administrative stuff and testing and design. Because here we are. This is the. I like your glass door. That is a really cool. What a great looking door. They've locked them out. Oh no.
Double lock.
This is administration and R&D. So the right at the back is Florian's office,
Right.
with the meeting table, and then we have here 3 desks for R&D, and then a desk for the head of production here for purchasing and everything, and then here we've got the admin. So pretty small scale.
One
area.
big space, and that's
It's
fine.
one big space. We
Yeah.
can communicate quite easily that way, and because we're not that many, so it makes sense to do it.
And
that way.
what goes on here?
So this is the prototyping area. So this is where we do all the testing of our equipment. So this area here, this area here is the area where we will do some work on the boards that we have. We have the microscope here. That's quite handy when you have to solve the really tiny parts. Or typically when you fine tune a circuit, you have to change the value of a resistor or a capacitor, and we've got these little boxes which are full of little components that we can use to do some changes. And this is the most crucial part, which is the testing area. So with this we have the same piece of equipment as the one that we have downstairs,
Right.
and
I
that
recognize it.
again allows you to have the generator that feeds into the unit, and then what's the output of the unit comes back into this testing equipment, and then with the computer you can check what you've got.
And you have a whole setup here of stuff and parts.
cables and also the piece of equipment, voltmeters and oscilloscope or.
And so it's not an everyday thing that you're working here and prototyping. It's not every day, right?
No, it's always a cycle.
Yeah.
It's a cycle. The first step is always to brainstorm. So we all meet, and Florian, who collects information from around the world, comes to the office with suggestion for the next product. Then
Right.
we discuss what we want to do, try and put some spec together of what we want to do, and then we distribute the work between all of us, and we decide in the sequence of how things need to be done. So always for a product, there's always some metalwork, some mechanics. So the mechanical engineer will create the outline and especially the inside of the products, and define the constraints, the physical constraints.
And are those are people that you hire on a project per project basis, mechanical engineers and things like that, or you have someone?
Well, there's 3 engineers. 4 with Florian is an engineer as well.
Right.
But there's 3 engineers working actively at making new products, including me.
Right.
So the mechanical engineer, the hardware electronics engineer, which is me, and the software engineer.
Oh,
So between the 3 of us, then we can define the tasks and then create the prototype. So that's the first step.
Yeah.
When you create the prototype, then you come to that place and then you can test it. You can make sure that what you have created actually complies to what
and
you
is that all
actually
done
measure.
that's all on breadboard type things?
Oh no! So
You go and make a circuit.
No. We always do real boards, which are as close as possible to the final thing.
Right.
And we test that, correct the mistakes, add the new things that we hadn't thought of at that point, or change the goalpost a little bit
Yeah.
to try and comply
And the
to what-
boards you outsource, right? You don't make,
the fabrication.
Yeah.
The fabrication is
which makes
outsourced.
complete sense. I mean, that's
So that's typical prototypes that we are doing.
wow.
So we love the green color for prototypes and the red color for production, so that there is never any
Confusion, right?
confusion or whatever. But as you can see, they are very close to the real stuff.
Yeah.
That's the analog in for the I1, the integrated
Oh.
amp, and the piggyback board that you can see here is the phonostage
Oh.
for the phonostage option.
Yeah.
The phonostage is the same as the current mode inputs that we have in the P1.
And if you want, oh,
So these So you've got the connectors here, so that allows you to connect the signal, go through it, and then with, for example, the oscilloscope, you've got the probes here. You can probe at various points in the board, making sure that every stages complies to what we want to, the performance that we aiming to achieve.
Right.
And then, we can sign off the prototype. Then we go through a second round of boards, which usually tend to be the production board, and that allows us to do what we call a pre-production batch. That allows us to make sure that everything is completely within the tolerances that we wanted. Because we can have, you don't want to have a board which is working and then you build 100 of them and they just out by a little bit because you haven't seen that one of the tolerances.
So what is the time frame between the time that you sit in there and brainstorm an idea and you end up with a finished product that you're ready to ship?
It's just below a year, the best part of a year.
Yeah.
We've been here for 10 years and we have 11 products. Yeah. So we have just nearly made a product.
So I don't want to give you a test, but you have 11 products. So what are those products?
Well, we started with the D1, which is our drive, and then we went into the C1,
Right.
which is our converter. We call it D2A controller, because by controller we mean that either you use it as a straight converter with no volume control, or you can add the volume control. But not only that, you also have this modular approach at the back, which allows you to also use, for example, Ethernet to stream or USB to stream. You can add analog inputs, and you can add the synchronization card as well.
Right.
First of all, for a customer who wants to change the way it works, the customer can buy an option card, for example, Ethernet card at a later stage, and fit it himself in the unit, update the firmware. There's a way you can update the firmware of the unit yourself. Then we did the X1, which is the...
No, it was the first amplifier.
Oh yeah, first amplifier, sorry. First amplifier, you're right. The A1, there's two channel amplifier, 2 times 100 watts. That sort of made a viable full system. You had the source, the converter with the volume control.
The volume control, right.
And then the power amplifier.
Right.
So for the first time there, we had a full system.
And then, after the
then we did the X1, which is an external power supply that is an option for the D1 and C1,
right.
which is also an option for the analog front end.
Yes.
And it's the way the X1 works is it regulates the voltage to DC levels. And then these DC levels get re-regulated inside the actual audio unit. So by adding an X1, you add a level of regulation in series with the existing regulation inside your audio unit.
Okay. And then after that came...
After that came the big M1.
Amplifier.
Big M1.
The M1.
Okay.
Yes. So the M1 is the big brother of the A1.
Right.
It's a 2 times 200 watts
Right.
amplifier.
Which I just reviewed.
Which
Okay.
you just reviewed,
Right.
yeah.
And positively, which is why they let me come here. Otherwise, they told me that they wouldn't have picked me up at the airport.
It was close.
They did. They told me
close,
that.
Actually.
Yeah. It was not a totally positive review, so they almost didn't pick me up, but they did. No, I'm just kidding. Just kidding. All right, and so then...
So that's the M1, so that was the... and then at that point, we felt like we needed to create a line preamplifier, a line stage.
The L1.
The L1.
Right.
The L1. So the L1's got 8 inputs, 4 XLRs, 2 RCAs and 2 BNCs, and then a series of outputs. And the volume control is an R2R ladder, and the tricky bit with an R2R ladder is to make sure that when you change the volume, it doesn't click.
Yeah.
And in order for it to not click, you need to make sure that all the DC offsets around the inside the unit is actually 0. And for that, we used a very specific system. But then we have A2Ds that will pick the signal at various critical points, measure it, and then we have a DSP that's going to process it to extract the DC component of it. And then DAC, they will inject the opposite of the offset to counteract it. And that's how we did it.
And you also have a click model for less money. and then does that fill out your original line and then you came out with the new line?
No,
There's more.
No,
wait,
something that you
but
own.
wait, there's
something
more.
you own.
Yeah, the phone.
Oh, the P1.
The P1.
Oh, yeah.
The phonostage.
Yes.
Yeah, of course. Yeah, we have a phonostage called the P1, and the P1's got 3 inputs. 2 of them are current sensing inputs, and one of them is the more traditional voltage sensing input.
Right.
So what is a current sensing input? Current sensing input. It's something that instead of reading the voltage across the coil of your cartridge, it will read the current that is generated by the cartridge. If you move a magnet in a coil, whether it's a moving magnet or moving coil, but if you move the two move, it generates a current, and this is what we harvest and amplify before we transform it back into voltage.
And moving coil cartridges are prodigious current producers, but
correct, because the impedance is very low.
Yes.
And that's the reason why these current sensing inputs are dedicated to MC cartridges.
yeah, it's almost a short circuit, right? I mean,
It acts as a short circuit. It's a virtual earth system, and that means that you force the cartridge to remain at 0, and you extract the current that comes out of it.
it works great. It does work great, I can tell you.
Did you like it?
Thank you.
And then the voltage input. For the voltage input, we felt like we had to give something more to our customers to help them with the loading problem. So the voltage input has got 500 steps of loading between 20 ohms and 100 kilo ohms, and you can swipe between all these, but you don't know what you should set. So you can follow what the cartridge manufacturer will say, but that won't take into account the cable, it won't take into account the input stage, it won't take into account the whole...
Not only that, but we know that 47K is a standard, but it's not really right for a lot of movement. It's just it's just a convenience thing.
Yeah.
So we decided to in order to try and help our customers, is we created a calibration record, and that record contains a specific tone, and that tone is then played on your turntable.
Yeah.
And you put the P1 into a mode which we call the loading wizard, and with that you are able to analyze the system, because what you are going to do is play from the turntable through the cable, through the cartridge, through everything, through all the way to the output of the P1, and at the output of the P1 we have an A to D again that will measure the signal. He knows what he's expecting because it's coming from our calibration record.
And when you're done with it, it holds it. You can go back. You can push the button.
And what it's going to do is it's going to process it with a DSP. It's going to process and extract the frequency response of your system. So you'll be able to see a line that shows the level versus frequency, and you'll see if it goes like this or if it goes up like this before it dips and everything. So by doing that, we are able to show visually what's happening, and with the wizard you can select a range of resistance, loading resistance, and then it's going to compute 20 curves across that range. And then with the buttons on the front panel you can scroll through all these and you can see the tendency of what's happening depending on how much you load your cartridge.
And I just play with that just because it's more fun than listening to music. It's actually playing that with that part of it. Sometimes I just go down there and do that and don't listen to music. It's okay. So
well, one thing, it also allows to check that the cartridge is well aligned and there is no big mistake into the turntable
big mistake,
setup. Because I've sometimes seen that you have 2, 3, 4 dB differences between the left and the right channel.
Yeah.
Or you see completely crazy things graphically, and you say, look, you should adjust your.
And it's not your phono
first.
preamp that's producing
exactly.
that. I know that.
Then let's play with the calibration.
Okay, so then after the P1, then you started working on the L series. I want to get to the L series before my hand gives out here.
No.
No,
be patient, please.
Wait, there's more.
The T1
There's the T1, yeah.
The T1, the clock generator.
Oh, that's
we call
right.
it
That's
T1, 10 megahertz time reference.
Right.
T for time. This is a clock generator that works at 10 megahertz. It's based on an Avon control oscillator. It's got the big block that we saw this morning, you and I saw this morning at the metalwork supplier, to try and isolate the oscillator from external perturbations.
Right.
It's an extremely low phase noise, or low jitter in a different word, oscillator, and it's got 6 outputs that can generate either a square wave or a sine wave with a high or low amplitude. And that allows you to connect to your digital systems, either the D1 and or the C1 or both.
So after the T1,
After the T1, we brought the I1. The I1 is the integrated, we call it universal integrated amplifier.
that we saw downstairs.
It's the one we saw downstairs,
Right.
yes. It has the same topology, architecture, which has got analog and digital inputs option cards. Factory fitted, it comes with one digital input card containing AES, SPD, Tosling, and the CH-Link HD, and analog line inputs, three of them. And then options, you have the telephone ringing. That's an option.
Can you add an Ethernet, streaming?
Yeah, Ethernet streaming,
Yeah.
USB streaming, and the external synchronization board. And then on the analog side, you got the current sensing phono input.
Oh, right. Okay, hold on one second.
The last product of the range
Yeah.
is the A1.5, and the A1.5 is a 2-channel power amplifier, and it replaces the A1 that we produced a bit earlier.
So if you remember, that was the third product into the list. So that was long ago.
Was the original A1?
It
It was
the original
our
A1.
first
Yeah.
amplifier,
Right.
yes.
And so, what does the A1.5 put out, power-wise?
1.5 times the power of the A1, so
Which was?
which is 150 watts per channel.
Oh.
That's how much it does, under 8 ohms. But just like all our power amplifiers, the inside, the power supply inside is more than capable of delivering much more. And on the A1.5, it's got a 1700 VA power transformer, which means that when you connect it in different modes, like a bridge mode or monorail mode, then you can get a lot more per channel.
All right, so then that completes your first cycle of products for almost
That's
10
right.
years.
Right.
That was
Right.
that's
And you've hardly broken a sweat. And then you decided to go upscale further.
That's right.
Not that you were
That's right.
downscale
we
before.
We felt that we had more to give,
Yeah.
and we decided for the 10-year anniversary of our company to launch a new series that we called the 10 series. And that 10 series is going to start with 2 products, the L10, which is the line stage, and the M10, which is the power amp. So both products and the whole structure of that new family is based on the 1 series of all the things that we've learned and experienced and gained from 10 years worth of development, and refining it by going to the extra topology, by refining the components that goes in it, typically using metal foil resistors in the signal path, and getting all the little bits and bobs extra in terms of headroom, in terms of low noise, distortion. Typically also in the L10 is going to be a new feature, which is the local versus global feedback ratio. This is something that we implemented in the power amp originally, but we decided to bring it to the line stage, so customers are going to be able to switch between fully global or fully local feedback inside the unit, just or on the fly.
Is it one or the other, or is there a ratio you can do like on the
It's
amp?
one or the other.
Oh,
It's
but
either
still-
local
It is a
or
global or local.
Yeah.
or global.
Nothing in
But
between.
then you can customize it to the music you're listening to at
That's
the
right.
push of a
Yes,
button.
that's right.
Yeah.
The sound stage is different. The immersion into the sound is different in local versus global, and therefore you'll be able to tune your preamp depending on the type of music you're playing.
No, what you have to do is create a series of stickers that people can put on their CDs or on their records that will say whether they decided this was better or that was better. Then they wouldn't have to guess or forget.
A sticker.
Yeah, sticker.
CH
Sticker. That's what I
CH
specialize in.
sticker.
Right. All right. So now we've really covered all your products essentially, And so there's one thing I got to say now that we're finished with this interview, and that is, I've been to a lot of places, and you guys, you don't have a sound room here. I mean, how could you have? In all honesty,
Sound room?
look, there's no sound room here
Why would you use a sound room?
because you have to hear what you take it home and listen. I mean, seriously.
We measure first.
Okay, but then what? Then what do you do?
I don't know. Maybe we should have a look over there.
Yeah.
You have another room?
Maybe.
Mm-hmm.
All right. Well, these people in Switzerland, they're so taciturn. You have to drag the information out of them. But they if there's a sound room here, I'll be very embarrassed. Whoa! Oh,
My goodness.
wait a second. not only is there a sound room, but there's an industrial spy here.
That's spying to our room.
There's a red-shirted.
Don't have my camera, I count on you.
You come here to see how it's done. What do you? The guy snuck in behind my back. Why don't you tell people who you are?
Who am I?
Yeah, who are you?
Hervé Delitra from Dazil Audio.
Okay.
I'm just a friend of this guy.
Even after this, you'll still be friends?
Don't know.
Okay.
Not sure.
So I think you guys have to sneak into his place when I go to do that, otherwise it won't be fair. All right, so let's look at the sound room here.
What we also notice is that the room is now empty. Hervé, what did you
Oh.
do with
What
our
have you
units?
done with the equipment that was in the room?
It's in my truck.
Okay, so I'm assuming that you took all your stuff to Munich. They're all suspected to go to Munich.
Yeah.
That's right.
Okay.
Yes,
Otherwise,
well,
we could listen to music, but we don't really have time to listen to
Sorry
music.
that the shelves are empty.
All right, so you got an Air Force 3,
That's correct.
and what have you got? You got the Tala's arm on it
Yes, exactly.
with a Tech DOS cartridge on it.
That's cartridge, yes.
And what else you got? And so you speaker-wise, you have
So speaker-wise, we have the Magico, the S1 Mark II.
right,
We have the M3 as well over here.
right.
Then we have the Goebel,
Which is that?
the Goebel, the German brand.
Ah, okay.
With the bending wave print simple, which is this is the bending.
Oh, yeah, planar magnetic center speaker.
Not really. It's a transducer which goes from 170 hertz to 40k,
And
So
this
it's
is
a
the
single
subwoofer
drum.
that goes with that.
and that's the sub.
And how do you spell this brand?
Goebel.
Oh, yeah. I know his
Yeah.
other speakers. I know that big giant thing. Yeah.
Exactly. Yeah.
Yeah. Okay. So now I know what that is. I can even spell it. All right. It's
And
Stenheim.
we have two Stenheim. So the regular one, the reference.
Right.
The 5 signature, and the reference, which is over here,
The big one.
the big one.
Okay. And when you play these, what electronics do you use to drive them?
Of course, the RZ amplifiers.
Are we having enough fun now? All right. I think we're done. Thank you very much.
My pleasure.
Thank you very much. Okay.